Hi and a very good morning everyone. So this is the video for the topic for operation on sets. For your information, this is the last topic for our unit. So let's go through this topic. Just gonna go through now. Okay, first of all, what you're gonna learn here is you're gonna learn about the intersection of set, unit of sets, and combined operation on sets. You also gonna use all these three to perform a simple task. Okay, the first thing that we're gonna learn inside this topic is the intersection of sets. So let's say you have two sets, which is set A and set B here. So when you have these two sets, so let's say we want to know the intersection. That means the intersection of element inside of A and inside of B. The one that intercept here is we call as the intersection of A and B. So we represent using this symbol, which is look like U, but it's actually not U. We just call it as intersection of set. Okay, so this area, the shaded one, is represented by A intercept by B. Okay, go through example. We have example A here, which is inside set A we have the odd number less than 10, which is 1, 5, 3, 7 and 9. And then also we have a element for B, which is 3, 6 and 9, 12 and 15. So all the elements in set A and set B are the common to set A. So now inside these two sets, find which one is the common element inside set A and set B. That means the one that is the same as inside of this two set, which is set A and set B. Inside this set A, do we have A? Inside B, so inside set A, we have the value of 1. Inside set B, do we have a value of 1? No, we don't have. Do we have value of 5? No, we don't have. Do we have value of 3? Yes, we have. We have 3. Do we have value of 7? No, we don't have. Do we have a value of 9? Yes, we have. So basically the common element inside these two sets is 3 and 9 here. So the same value, this common element is called as the intersection of sets. Oh, sorry. Okay, now moreover, in this area set and set B is where the two sets overlap here, which is 3 and 9 overlap with the common element inside set A and set B. We call it as the intersection of A and B. The gray color region is the region where the intersection of two sets meets. Okay, the symbol of intersection is this one, which is looks like U. It's not U. The looks like N, or yeah, looks like N. Okay, so how to write this intersection of set A and set B? So A intercept B equal to, and then write the element that is intercept, which is 3 and 9. Okay, now we go through example. The first they give to you, it is given that universal set, which is an integer between 1 until 10. This one is the universal, which is starting from 1 until 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set B is an odd number for the universal set, which is odd number, right? So odd number we have 1, 3, 5, 7 and 9. And here we have set Q, which is a prime number from the universal set, which is 2, 3, 5 and 7. This is the prime number. And then now the question asks you to list all the elements in the following intersection. So we have P, we have Q, we have universal, which is this one, And the question B asks us to state the number of elements of the following set. State the number of elements of the following set. Number of element, which is the P intercept with Q. So P intercept with Q is, if we need to see which one is the common element inside P and Q. So first we have 3, 5. This one we have 3. This one we have 3. We have 5. We have 5. We have 7. We have 7. This one we have 9. Do we have 9 here? We don't have. Do we have 1? We don't have. Do we have 2? We don't have. So that's why the common element here is 3, 5, 7, which is the intersection is P intersect Q equal to 3, 5, 7. And the number of element here is equal to N P intersect with Q, which is N here represent the number of element. So to calculate number of element, just calculate 1, 2, 3. So the answer is 3. Okay, now the next one, the intersection of two or more set using Venn diagram. So let's go through with this example. Now we just want to shade the intersection. So let's say they told you here we have P and Q element, and then we want to find the intersection of P and Q. Should be the one that intercept here. What about this one? P intercept with Q equal to Q. Why? Because Q is only this guy. So when we intercept P and Q, obviously this one will be the shaded one. Okay, and then P intercept with R. So where is R? This one is R, this one is P. So to find the intersection, find the one that is actually intercept with each other like this. So what about the next one? P intercept with Q, intercept with R. So we have P, we have Q, we have R. Find the one that is intercept. Should be this area. Okay, the next one, intersection. This one we can go through the example. So the Venn diagram show that set J and K and L such that the universal set of this. So list all element of the following intersection of set. So first they want us to find J intercept K based on this diagram, and they want us to find J intercept with L based on this diagram. So now for J intercept with K, so this is J, right? J, we have 1, 4, 6, 7, 9, 5 and 3, and K we have 5, 3, 2, 8. So we want to find the intersection between J and K, right? So J and K, the intersection is here. So basically the intersection element inside is 3 and 5. Okay, now yeah, I want to delete this one. Oh. Sorry, yeah. Okay, now for J and L, okay, we delete this one first. Okay, for J intercept with L, we have J here and we have L inside, right? So where is the intersection? This one is J, this one is L. So the one that is intercept is this guy. So basically the intersection is 5, 7 and 9. So we have this one. Okay, the next question, it is given that set A, the number on dice which we have, A is equal to 1, 2, 3, 4, 5 and 6, the number that is on a dice, right? And we have we have set B, which is even number on a dice, which is even number on a dice is 2, 4 and 6. And set C, they give us this. List all the elements of the following intersection of set. So we want to find A intersect with B. So for B is this value, right? So A intersect with B, we will find A. Do we have 2? Yes. 4 do we have? Yes, do we have. 6 do we have? Yes. So basically A intersect with B is 2, 4, 6. And the element for B intersect with C. So B we have 2, 4 and 6, right? Here we have 7, 8 and 9. Do we have any value intersect? No, we don't have. So that's why we just type it like this. Write it like that. Because we don't have any element that is intersect with each other. Okay, the next one, intersection of two or more sets using Venn diagram. So here we have the question asks you to draw a Venn diagram to represent the set A and set B. Shade the region that represent each of the following intersection of set. So now we have A, B, which is the square here, and the C. So we need to find the intersection of A and B. First, just shade, right? So A, this one, intersect with B, which is this one. So the intersection, so it should be inside this one. And then here we can just write all the elements in set B are in the set A. If you don't want type explain this also can, just draw and then shade the region. And shade the region B intersect with C. So B here intersect with C. Do they intersect? No, they did not intersect. So that's why we cannot represent it using the shaded region here. So how? This one you can delete. Okay. So the next one, complement of an intersection of set. So complement of intersection of set for P and Q is represented by this symbol, which is P intersect with Q, which is prime here. What does it mean? The set is which is not intersect by P and Q, the element that is not intersect for P and Q. So basically here we intercept this value, right? We intercept P and Q, right? But what does it mean by complement? Other than the one that is intercept. Supposedly P and Q intercept, it is here, right? But for complement, the one that is not intercept. So basically all of this. Not the one that is in white color. Okay, go through example. Given the universal set is x is an integer between 1 until 8. So a universal 1 until 8. And then set A is equal to 1, 2, 3, 4, and 5, and 6. And B is 2, 4, 6. List all the elements and state the number of elements by the following sets. Here we want to know the complement of A intersect by B. So first of all, just find the value of A intersect by B. So this value of A, which one is intersect by B? 2, and then 4 and 6. And then now we want to know the complement. So that means other than 2, 4 and 6. So use the universal value here, which is you just find the one that is not 2, 4 and 6. So this one 2, 4 and 6, right? Find the one that is not 2, 4 and 6. Then it should be 1, 3, 5 and 7. 1, 3, 5, 7 and 8. So now the question asks you state the number of elements. So you have 1, 3, 5, 7, 8. Calculate, you're going to get equal to 5. Okay, the next one, complement of an intersection of set. So here you have A, B, intercept B, intercept C. So find A, intercept B and C, you're going to get 2, 4. And then find the complement. So that means other than 2, other than 4. So you're going to get 1, 3, 5, 6, 7, 8. So get this one. And we want to state the number of the elements. So it should be 6. Okay, the union of set. Union of set, it is actually for both of the sets, and we represent using the U shape. Okay, A union A. So we can see the union of set using the shaded regions in the Venn diagrams below. First of all, if P union with Q, so we're going to include all the elements inside P and Q. Here also we're going to include all the elements inside this. What about Q and R? We're going to represent using all of the element of Q and all of the element of R. Also the same for PQR, which is consists of all element inside the Venn diagram. The next one, union of sets, where we're going to go through example. There it is given that factors of 24, P is equal to factors of 24, Q is the multiple of 3, which is less than 20, and set R is the multiple of 4, which is less than 20. So the question asks us to list all the elements of the following union set and draw a Venn diagram to represent P, Q and R. So list all first for element Q, P, list all element Q, and then we want to find the P union Q, which is for all of this value. Now you can just create a Venn diagram here, which is consists of all elements for P and Q and also R. But R we will not shade it at this part because 16 is not inside P, is not inside Q. Okay, the next one is P union Q union R. So list out P, list out Q, list out R, and then if it is union, then we're going to include all of the element inside P, inside Q and inside R and shaded everything. Okay, complement of the union sets. The complement of the union set is read as the complement of the union sets of P and Q. This is referred to all of the element which is not inside of P and Q. More complement in union of set represented by the shaded region in the Venn diagram below. So let's say complement for P union Q should be outside of P and Q. So you shape this guy. Okay, let's say P and Q also outside of them. So what about P union Q? So P, right? Union Q, union R, sorry, you're going to get this. But we want complement should be other the one that I shaded just now. What about this one? P union Q union R. So shade every element here, every element here, which is P, Q and R, and then the one that is complement is outside of the one that we shaded just now. Okay, the union sets given the universal set is an integer of 50 until 60. So universal 50, 51 until 60. And then it is explained here, G is the prime number between the universal set and H is the multiple of 4. I is the multiple of 5. List all the element and state the number of element in the following set. So the first one is G union H, the complement, and complement of G union I. Okay, first one. Oh, sorry. Okay. The first one, we have we have universal set starting from 51 until 60, and then for G, we have multiple of for set G, it is a prime number, so that's why we have 53 and 59 is our prime number, which is coming from the universal set. We have H here is the multiple of 4, which is 52, 56 and 60, and I, we have multiple of 5, we have 50, 55 and 60. So here we want to know G, the complement of G union H. So find G union H first, which is 53, 59, 52, 56 and 60. Then find the one that is not from this value, which is we're going to get 50, 51, 54, 55, 57, 58, and calculate the number of element. So you're going to do the same for G intercept with G union with I, and find the complement, and the value of the number you're going to get equal to 6. Okay, now combine operation on sets is involving both intersection of the set and also union of the set at the same time. So let's go through example. Let's say we have given set P Arif, Emmy, Iris, Ellen, J, and set Q Lily, Emmy, Iris, Ellen, May, and Ani, and set R Zarif, Jita, Iris, May, and J. So list all the element of P union Q and intercept with R, and also draw a Venn diagram and shade the region that represent P union Q intercept R. So first of all, we have P, we have Q, we have R. So find the union of P and Q. So we have Arif, okay, Arif, Emmy, we have Emmy, Iris, Alan, and J, Lily. Also, we already put Emmy here. We also put Iris, also Alan. We put also May. We don't have May yet. Then put May. Then Nani, put Nani. Then now R is Zarif, Gita, Iris, May, and J. Okay, this one. Now we want to find this one intercept with R, which is this one. So we're going to find the same one, which is J. We have J here. We have May. We have May here. Iris. We have Iris. Gita. We don't have. Okay, no, we don't have this one. Zarif. Do we have? No, we don't have Zarif. So the answer will be J, Iris, and May. Okay, the next one. Let's say we want to use combined operation. We want to shade it. So if P shade with Q, so shade everything, combine. P is union with Q. So let's say the next one, we want to know R. So just like this. Let's say the next one, we want to know P. We have P and Q and R. Okay, first we find P union Q and then we find R, right? So for this one, we just find the one, and for R here, we just find the one that is intercept to each other. So we can see that all these and this are intercept to each other. So that's why your answer for the shaded region of P union Q intercept with R is this one. Okay. The next one is the complement of combined operation on set. The complement of combined operation on set involve either the complement of intersection or complement of union set for both intersection. So give an example for you. Let's say we have integer of 30 until 40, and then set A is a multiple of 3, set B is the sum of its 2 digits is odd, and we have set C. So now we need to list all the element for A intercept U, which is we find the complement, it's not intercept. Complement of A union B intercept with C. And then now, after that, find this element, draw a Venn diagram and shade the region. Okay, now list out the universal set, list out A, list out B, and list out C. So now first of all, we want to find out the complement of A union B. So A union B, combine these two, and then you're gonna get 30, 32, 33, 34, 36, 38, and 39. From all of these, find its complement, which is not included. So 30, 32 cannot, 34 also got yeah, and then 36 cannot, 38 cannot, 39 also cannot. So here 31, 35, 37, and 40 is your complement for union A and B. Now we are given a value of C. We need to find the intersection. So 31, do we have intersection? No, we don't have. 32, do we have? No, we don't have. 35, yes, we have here. So which is, we got 35. 39, we don't have. 37 also we don't have. 40, yes, we have. So we have this one. So this is how you shape the region. Okay, that's it for this topic. If there are any question, you can just ask me. Okay, thank you for listening. Bye.